Well, pre-calculus classes, good morning, good afternoon, or good evening. I know we're on AMI day number 4. Who knows? We may end up with number 5. I've had a couple of inquiries about maybe a little better directions than what had been typed up for this, and I can certainly put together at least a little bit of a video here to kind of help with that. First is, when they talk about what your graphing calculator needs to be, again, if you're on Desmos, Desmos is already set up pretty well for that, but what you can do is on your calculator is first do go in, double check, make sure. I know a lot of the SOHCAHTOA stuff we've been doing, we wanted your calculator mode in degrees, so go ahead, change that over to radian. And then on your window, I would go ahead, the X and minimum and maximum, like it says there for those, just negative 2 pi, positive 2 pi, so just negative 2 pi, positive 2 pi. You can leave the scale, for the X at, or change it, I guess I should say, 2 pi over 4. Your Y's you can shrink down to like negative 4, positive 4. The Y scale you can certainly leave at 1. And then the resistance, if you just leave that at 1 as well, or the resolution, that's fine too. But anyway, that should at least kind of get things set as far as what we want for your window. And then when it talks about like each quote-unquote problem, I'll even kind of do an example or two of those, if nothing else, just to kind of help you out there. So one of the things we do want you to do is, like when it says graph and label on one set of axes, y equals sine x, y equals 3 sine x. Well, if you go into your y equals, clear out anything that's currently in there. And so one thing you might even want to do is initially, like when you graph sine x, if you want to even go ahead and, before you actually worry about the second one, the 3 sine x, if you want to actually look at this one, and then on your actual graph paper, let me kind of get these to where you can see both at once. So here is example 1, and then you can see here basically what they've done. Eventually we're going to get to where you don't actually graph on grids and you don't have to have all of these so evenly spaced. There it's kind of up to you. I'll even use just a scale of 1 there. But if you look, you can see origin, and then you've got your x-intercepts there, and then you have a maximum that's at pi over 2. There's your minimum at negative, or at 3 pi over 2, so kind of like the graphs we just did for the test. And then if you go back to negative 2 pi, there is a minimum and a maximum as well. So there is a rough sketch of sine x. Now if we go back and look at 3 sine x, I am going to go ahead and keep same window there, and 3 sine x, and then when you graph, it's up to you. I do think it does help if you use a different color for the second graph. And so you can see here, really all that's changed is we now have the maximum is steeper. It's now at 3. The minimum here is at negative 3. And you can have that as, part of that graph. And then there is that minimum and that maximum there. And so that would be example 1. Well, when you look at, kind of back to the directions page, Then we want you to leave sin x in there. So, but clear out that one. And then just enter in, 1/2 sin x. So obviously you can see there is the original, kind of your parent function. Now you can see the 1/2 sin x drawn in there. And so we would just want you to do kind of the similar thing on a second grid there. Then when you get, and then also with example 3, I'm not going to graph all of those, but here I'll even, if you want, clear that out. -2 sin x. Hit graph there. So again, it's going to draw essentially what we're going to treat as our parent function. And then there is the -2 sin x. Now, question 4 says make a conclusion. Here, let me zoom back out just a little bit about the graph of sine and the other graphs, meaning what transformations are represented in these graphs. Well, this is where we want you to go back to your, think about first semester project investigation where we did all of the shifting, the stretching. We're saying, okay, what transformations do you see here? Well, is it a shift? Is it a stretch? We just want you to kind of in words use that. And so then like on each of these, there is a term that does come into play with, all of the different transformations. And so then when you get down to question number 6, basically what we're saying, you don't actually have to put these onto paper, but if you go back in and look at, if you anywhere where you have a y equals, if you replace sine with cosine, so go back to even example 1, there's cosine x. I'm going to clear that out, just quickly graph it. You can kind of see there is your parent function from what we just graphed on the test. Well, now go in and enter in 3 cosine x. And you can kind of compare and see, okay, whatever you said here is, what transformation did you think this was? Is it any different when you interchange sine with cosine? And so that's kind of what we're wanting you to do. We'll give you, if we're in school tomorrow, we'll give you time to work on this, maybe even go a little more in depth with some directions for you with that. If we're not, like I said, hopefully this maybe at least adds a little bit more clarity. But basically for each one of these, we will, we do want you to have not only the parent function sketched, but also the one with the transformations. And again, we're just kind of wanting you to think about the transformations we used first semester with all of your algebraic graphs. That was kind of a lead into now as we're working with the trigonometric graphs, mostly with sine and cosine. We're not going to use any stretches, shrinks, shifts for the most part with tangent moving forward. We want you to know what that graph looks like, but we're not going to ask you to do any transformations with tangent. But we are going to use sine and cosine quite a bit with those transformations. So again, hopefully this at least provides some additional clarity to this. And again, if you do have any questions, certainly feel free to email us if you do need some additional help with this.